Okay, welcome. So in this video, what I'm going to be doing is just showing you how to set up the a project which just a small project which I've put together, which helps to test out the NVS on ESP32. And so in order to get a hold of the project, what you do is go to Codeberg. If you try and search for it on Google or any other if you try and search for it, it probably won't show up yet. So if you just go to explore, and then if you go to basically it's just go to users and just go to Mac PC. And so you go in there. So far I've only got the one project, but just in case there might be some others. And so if you go into there, and what you see is the information for it. And so what we do next is there's two ways you can do it. You can clone it, but if you don't really want to actually clone it, you can just use one of the tags that I've created. And so the latest tag is this one, which is 0.1.1. That's the one I'm going to be testing out. And so to download it, you can just download it to any location that you want. Okay, hold on a second. Okay, so I've saved that in just a temporary directory. And so now what you want to do is just decompress it. Right, so that's decompressed it. So now, if I change into the directory, right, so the next thing I have to do is to actually I'll just go quickly do something because right. Okay, so now in order to be able to compile it, what I have to do is to there's just some configuration variables that I just have to set up. I mean, this is just for me, but you'll find that it'll actually be different when you try to do it yourself. Because what you really have to do is use the instructions that are with to set up the esp-idf for your particular whatever platform you're on. So these are just examples. So your IDF might be in a different location, and also your tool chain might be in a different location as well. And then this is just the equivalent of me installing the driver, because on Windows you have to download something, etc. But all I have to do is probe a module, and then that would then mean that the driver is installed. So now the next thing to do is to you have to do make menu config. So because I'm still on esp-idf 3, that's why I can use make, but in 4 apparently they've gone over to, oh yes, alright, yeah, I think this is just a problem with my terminal. Right. Okay, so normally you don't really need to configure anything for this particular project, but you might want to change some settings. Like the main thing you want to change is the speed of your serial port. And so I've got it as 11520, and then this is the COM port I'm using, which is TTY USB 0. And so if you just select use right arrow and then exit, and it doesn't show up on this terminal. Right, so now that's the configuration done. So now, yeah, so now you just have to build the project. And what I'm going to do is let me just, yeah, that's not doing much. So we do make flash. Right, so now that's compiling. Alright, so now it's uploading. You won't see much happening on here. So it's just uploading this. Right, and then so I've uploaded, but what you notice, nothing much is happening. There's a reason for this. It's because the flash is actually full. So the other thing I need to do is actually erase. Actually, I did the wrong thing. I should have erased it before. You know. Because what actually happens is that I've made it so that it stops operating once the NVS is full. Well, it reaches up a certain size. So if I, yes, we do the erase flash, and it should see it starting to run. Alright, now you should see the light start blinking. Right, there you go. And see what's actually happening. Right, so what I'm going to do is run minicom. Alright, and you can actually see the output. So what's happening, you see the LED, what it's essentially doing is the LED is off, and as you can see the number is one which is getting bigger, another number which is getting smaller, and the character is a char, and that's going up by one letter. And as you can see, each time around, the LED is either on or off. And so if you make a note of what you see there, so see it says, you can see the NVS is a certain size. And so what I'm going to do is I'm just going to take the power out. Alright, so power's off. Just resetting. Alright, yes, I think what's happened is it's still got minicom's holding the port open. So if I turn it off and just quit out of minicom. Alright, looks like minicom's a bit hard to get rid of. Alright, yeah, finally. Right, yeah, so what happened is minicom was blocking the device, so I should really put minicom first. So now if I plug it back in and then run minicom, right, so you notice that the number's at 20 now, and the NVS string is still the same, similar size as before, and as you can see, it's still going up. Alright, so now if I yeah, so you can see that it's getting larger, and so even if I do that again, minicom, and then take the power out, yeah, so you see the power's off for definite. And put the power back in minicom. Alright, you see it's up, and you see the numbers. The text, NVS text is still there, and numbers are still going up and down, and of course the LED is either off or on time, so it'll actually store the where it is. So let's try and just do one more thing to see if I can get the LED, because you saw the LED was on when I turned it on last time. So if I wait to go off, alright, yeah, so it's too large. So now the LED is going to be stuck on. So the only way out of this is now I've just got to restart it. So if I quit out, sorry, restart, I have to reflash it. So now if I just erase, well, I'm going to erase it, so all the flash is going to be gone. So if you just do erase flash and then flash it again, now back to minicom. So as you can see, now the NVS is small again, and you can see the numbers are back to the small. Well, one's smaller, one's close to 1,000, and the letter is started from A again. And what I'm just going to try this last time is just to, because last time I turned it on, the LED was on because it was on when I turned off the power. So now this time what I'm going to try is I'm going to try and take the power out when it's off, just to show that it will actually be off when the power comes back on. Okay, so it's off. So now if I plug it back in, oh, it's on. Okay. Maybe what I think timing was bad. Let me try. So it's on. It's off. Oops. It must default. Yeah, let's see why it doesn't. Oh yeah, so it's off now. I think it boots on, then it's on. So I think it always boots on. So if it's on, it should stay on for longer. Let me just try. Oh, see, oh, that's strange. Oh, I think I know what's up. So if it's off, then I think the value's already stored. Yeah, it's to do with the web and the logic. So whatever you see, it's stored as the opposite. So when the LED is on, it gets stored as off. Yeah, that's right. So then when it's on, if you pull the power when it's on, it will be off. And if you pull the power when it's off, it will be on. So let me just double check that. So I'm going to try and pull it when it's off. So then if I plug it in, it will be on. Yeah, so it's on straight away. And if I pull it when it's on, it will be off. Right. So that's the power. So when it goes in, it should be off now. Yeah, so that's it, right. Yes, that's just the logic in the code. If you look at the code, you'll be able to see why it does that. Okay, thanks for watching, and hopefully this code will be of use to someone who's using the ESP32, since I've noticed that I haven't really found anyone else who's even interested in the NVS for whatever reason, but as far as I can see, this NVS is actually quite a feature on this chip. Right, so this is just a quick addition. I forgot to I went on Codeberg, but I didn't even explain what I'd written. All I did was just showed you how to get the code. So just going to quickly show that the main C file is in the NVS, this NVS value example. So this is just from the esp-idf, and it's pretty straightforward. But this font's pretty horrible, isn't it? Don't know why they keep choosing these horrible fonts. Oh, well, yeah, it's just it's annoying that they make the color so faint. I don't know who they think is going to be able to look at text which is so grey. Right, so anyway, you should be able to see it a little bit better now. So what I've done is I've taken the example, and so all of this is from the standard example that comes with the esp-idf, and the only changes I've really made is that this is what I wanted to show. So this is the structure that I'm actually storing the information in, and so I've got a variable. Well, the first variable here is where is it? Yeah, it's buff size. So this is just size of the text structure. Sorry, the text inside the structure. So if you want to make it bigger, all you have to do is just change buff size. And the good thing about this is that everything it's actually auto sizing. So if you add a load more, whatever you want in here, like you can add, any kind of data type. You want loads of ints and more character buffers, even static text or whatever you want. And everything that you put inside this struct will actually be stored in the NVS. And it doesn't matter what the data type is, because good old C, all it is just writes bytes into memory. So the bigger the struct gets, is just the more bytes get written into the NVS flash. And what I've actually done is that everywhere in the code where it references the struct, always does size of. So it's size of here, size of here. And because I've used size of for the struct, it will auto size. It will auto size no matter how many no matter how many different sort of variables you put into the struct, the code will just take it. And of course, you can put a whole load of stuff in here if you want, until obviously the NVS, because I don't think it'll tell you when it's too large. I think it either it won't flash or it'll just crash, but of course it will tell you in the log. But essentially, the other thing I was going to say is that when I looked up, I was thinking of putting more than one variable straight into the NVS, but it's actually very annoying to do, because for each variable, you have to recreate all of this initialization to actually get the information out of the NVS and to put it in. And you've got to do it in this order. So if you don't do all of the stages that that it requires in order to take the stuff out of NVS and put it back in, then you can end up corrupting your data if you don't complete one putting of data in. Because the reason why it's difficult is because when you open the NVS, it actually asks for a handle. Yeah, so you've got this NVS handle and you open it. So I've opened it with the name of storage. Now the thing about it is, yeah, maybe you can try opening another handle with a different name, but personally I wouldn't waste the time trying to do something that difficult. So I found it easier just to create one struct, and then just whatever you want in the image, just put everything into here, and then you only have to do all of this NVS stuff once, and it's just a lot easier to program. So this was just to show you quickly how I set up the code in such a way so that rather than just being one variable, now you can put however many variables you want into the NVS of the ESP32.